Hello everyone. Today the second lecture of ionic bond, chemical bond. This is the second lecture in which we are going to study about ionic bonds, metal plus non-metal. At first we will learn that ionic bonds are typical ionic bonds forms between metal and non-metal. Metal denotes electron and non-metal accept electron. There is a complete transfer of electron. Actually, there is no bond formation between the atoms. There is only force of attraction, that is electrostatic force of attraction. That is F is equal to KQ1 Q2 by a square of R. This is a strong force as R is very short. There, if there is a distance between them is sorry, I should try it again. Let's sodium. Let's move further. Na plus Na after donating an electron or removing an electron, it becomes Na plus. Chlorine after accepting an electron becomes chlorine having negative sign. Its configuration is electronic configuration is 281, 28, 287, 288. Now the next question arises, they become stable, their octet has been fulfilled, then why they are going to form a bond? The answer is that they are gaseous atoms. They are gaseous atom, and they when they attract towards each other, there there is a loss of energy, that is called lattice energy. And we have learned in previous lecture that the bond formation is occurred to achieve low potential energy. Next topic, we should learn that Na plus, the amount of energy, the amount of energy requires to remove an electron from an isolated neutral gaseous atom is called ionization energy, while amount of energy released when an isolated gains an electron is called electron affinity. Now we are going to study about Lewis dot structure, LDS, Na plus chlorine, sodium plus chlorine, NaCl, gaseous atom 28 uh, gap 288. They form NaCl solid. Na. There are two ways to form a Lewis dot structure. The first one is this one, Na plus. It has already donated an electron, and this time it is about to donate an electron to chlorine atom. MgCl2, Mg, Mg2 plus electron, 2 electron. It has removed 2 electron, 2Cl plus 2 electrons, 2Cl. Here there is a Lewis dot structure of electrovalency. Now we are going to learn about electrovalency. Number of electrons lost or gained during the formation of ionic bond is called electron valency. Number of electron lost or gained during the formation of ionic bond is called electrovalency. Electrovalency is always positive. Now let us take a glance in electrovalency of different groups. Group 1, lithium, sodium, potassium, rubidiums. The electrovalency of group 1 elements is 1 and 2 is of group 2. From 3 to 12 they are they belongs to from group 3 to 12 they belongs to d block elements and have variable variable electrovalency. We will discuss in our further chapter in our further chapter we will discuss it ahead. The electrovalency of group 13, at first we should know about the important atoms in group 13 like aluminum, gallium. It has electrovalency 3. 14, carbon. Group 14, they do not forms ionic bonds ionic bonds, so we do not consider their electrovalency. Electrovalency is of ionic bond. Group 16, oxygen, silicon, sulfur, silicon, titanium have electrovalency 2. Chlorine, chlorine, bromine have valency 1. Their variable iron plus 2 depends upon the variability of the group D elements depends upon with which atom it is going to form a compound and who is on the other side to react. Next topic is what is the next topic is terms of energy involved in the formation of ionic bonds. Favorable conditions. At first, metal metal is going to lose an electron, lose electron. This is called, and when an atom lose an electron, energy is absorbed. The amount of energy absorbed is called ionization energy. Non-metal energy released, electron affinity, it is known as electron affinity. Metal plus non-metals, and plus is energy released then forms, this is called lattice energy. When 1 mole of ionic compound is formed from gaseous cation and gaseous anion, the amount of energy is released is called lattice energy. Now I think today's class is over. No, today's class is not over. There are some few questions. There are few questions which I have to deal with. I have to deal with which is most ionic covalents. The most covalent, the metallic character as we move from upside to downwards in a periodic table we find non-ionic character decreases while vice versa, while in contrast of the first ones, metallic character increases as we move towards downsides. There are some questions, we should take care of all these properties of ionic bonds. Their physical state solid. Ionic bonds forms a solid. Melting and boiling points are high, because electrostatic force is very high. Conductivity, bad conductors in solid states, but however is it is a good conductor in molten and aqueous states. Why? Because comparisons to the air force of attraction decreases 81 times in water, and in molten states we know that electricity needs charge to flow, is all about flow of charge. And in molten forms they become separated, they are separated, so they became anion and cation, and that is all need to flow of an electricity.